Okay, so for this video, we are looking at ionic compounds, which is a metal and a non-metal. So same thing as last time. I have a few examples right here. Go ahead and pause the video. Try and see if you can figure out the patterns and the rules for how we named these. I will tell you this bottom one is kind of a tricky one, and it's meant to be a little bit of a tricky one. Go ahead and see if you can figure anything out. Like I said, there's a few more rules to ionic compounds than there are for covalent, but they're still not necessarily that difficult. Hopefully you took a look at that. Before we jump into actually how to name them, again, a couple things we want to know before going in. Ionic, like I said, is a metal and a non-metal. And then new vocab that we haven't heard before is a monatomic ion and a polyatomic ion. So the prefix mono means one, poly means many, right, or multiple. So kind of exactly how it would sound. This first one is an ion consisting of one atom. So if I had like calcium plus 2. Right, it's an ion, so it has a charge. Sodium plus 1, bromine minus 1. Those are all monatomic ions. There's a single element with a charge. A polyatomic ion is an ion consisting of more than one atom. So for example, CO3 with a minus 2 charge. And these polyatomic ions, when we try to name them, they get a little bit trickier. You are given the names of a lot of polyatomic ions. They're on the back of the periodic table we'll use in class. And we will talk about how to name these specifically in person. So I'm not going to talk about naming these in this video particularly. There might be another one where I do. We're going to focus on just basic ionic naming and monatomic ions. So the rules for naming ionic compounds, the basic rules, right, for kind of every compound we're looking at. The metal always comes first. So, for example, down here I have aluminum and oxygen. Aluminum is going to come first. So the cation should be the first thing in the name. Then same thing with covalent. The second element is going to get that IDE ending. So I have aluminum, right? That's my metal. Then I turned oxygen into oxide. So I just changed that ending, just the same as covalent. And then here's the tricky part, especially with transition metals. And we'll deal with these a little bit more in class as well. We have to use this thing called the crisscross method to figure out what numbers I need in the formula. And I'll show a picture for the crisscross method in a second, but let's just look at this example down here. So aluminum oxide, notice my little caption down here. Notice aluminum came first, right? It's the metal. Oxygen was turned into oxide with that ending. And here's where I got those numbers from. So we know that oxygen has a charge of minus 2, right? It has 6 valence electrons. It wants 2 more. We also know that aluminum has a charge of plus 3. So all we really did was we took those two numbers and swapped their element, right? So the 2 that was from the oxygen is now on this aluminum. The 3 from the aluminum is now on this oxygen. So we call that the crisscross method. To give you a visual for that, right, the charge just goes on the opposite atom, just like this. So we can kind of take apart those two pieces and swap the numbers. That's why we call it the crisscross method. One thing to note is that if we ever have a plus 1 or a minus 1, we don't need to write that, right? It's kind of assumed if it's not there. But that's the crisscross method. It's really not too bad. This is going to be particularly helpful for transition metals, like I was saying, because sometimes transition metals can have more than one charge, right? Sometimes I might have plus 2. Sometimes it could be plus 3 or plus 4. A really common example is lead. So lead right here can usually be a plus 2 or a plus 4. We'd really have to pay attention to which one it is in the name to make the formula, or pay attention to the numbers in the formula to figure out how to name it. And we'll practice that specifically in class. That's probably the trickiest part with naming ionic compounds, is what is the charge, what numbers do I need? We usually write those numbers in the formula, or in the name, sorry, with Roman numerals. So like I said, we're not going to do that in this video. I'll make a separate video where I focus specifically on that, and we'll be practicing that for the most part in here. I'm going to jump back over here. So that's the crisscross method. Now let's zoom in on the monatomic versus polyatomic, right? So one atom versus having multiple atoms. So for example, how we name those, if I just have a single ion, all I do is put on the IDE ending, right? So chlorine minus 1, I would call chloride because it's an ion. Sulfur minus 2, I would name sulfide because it's an ion. So if they're just a single charged element, we just add that IDE ending. So that part's not that bad. Polyatomic are a little bit weirder, right? They have more specific names. So for example, OH minus 1 is hydroxide. NH4 plus 1 is called ammonium. These are harder to just predict. So like I said, for all the polyatomic names, you're provided those. So you don't have to memorize them or anything like that. We'll provide those for you, and we'll practice naming with them in here or in a different video. All right, this is the part of the video where I'm going to want to have you pause and try to solve it on your own, whether you write it, type it, think it through, any of those are fine. So polyatomic ions will wait. These are just the basic ones. So my first question is write the formula for sodium phosphide. So now would be a good time to pause the video and give it a try. All right, hopefully you tried that. So here's what we want to look at. So we know sodium is Na. Right, so I'm just going to write this stuff down, and I'll go back and fix. I also know that sodium has a +1 charge. That's kind of the first piece of information. Then I know I have phosphide. So that tells me it's phosphorus. Right, then I have to figure out what's the charge of phosphorus, because that's pretty important. So phosphorus, I know my screen's kind of blocking it right here. If it's in group 15, that means it needs to gain those 3 electrons, right, to get that 8. So it's going to have a -3 charge. So I know I have sodium +1 and phosphorus -3. I have to use that crisscross method, meaning the 1 is going to go to the P, the 3 is going to go to the Na, so I'm going to write Na3, and this would be obviously smaller. P, and then I can write a 1, but I don't have to. So I could, and I'll just go ahead and shrink this real quick to look a little bit better. There we go. I could just leave it like that. And that would be the formula for sodium phosphide. My second question, again, pause the video here, give it a try on your own. Hopefully you did it just fine. So what I notice here is that it's a monatomic ion, right? Just a single ion. So I have Br, which is bromine, -1. Since it's just a monatomic, a single atom, all I have to do is change the ending to IED. So it would be bromide. And that would be it. And that's where I'm going to end this video. We'll be practicing some more specifically of number 1, just that crisscross method. We'll look at transition metals with different charges, and we'll look at polyatomic ions in class together. But that's all I have for you in this video.